To section 2 of chapter 3, a little quick review of what we've done in section 1. Now if we plot and graph one line and plot and graph the other line, this point of intersection is given as an ordered pair. This would be a solution for both the black equation and the blue equation. We say we have solved these equations simultaneously through graphing. And this point of intersection is this common answer to both of the equations. So we say that this set is consistent in that there's at least one point of intersection, but the graphs are independent in that they are different lines. Now in this second instance, we said if we graph the first line and graph the second line, they had the same slope, but different y-intercepts. There are no solutions. There's no point of intersection. So this would be inconsistent, and the lines are different, so they are independent. And then in our third type of example, we said if we plotted the first line and the second, and they happen to go right on top of the other, the equations were actually the same. They may be disguised through some process of equivalency or something, but since they are the same equation, the equations are dependent. And since there's at least one solution, they are consistent. Now, what are we going to learn in section 2? Well, in section 2, we're going to solve these equations by substitution in some cases, elimination in other cases, and we'll go over these methods as we go through the lesson. But why do we need other methods? Well, what I've done down here is I've drawn a black equation and a red equation, and notice where they are intersecting. They're not intersecting on the grid line. So you can't pull out some nice ordered pairs. You're going to have a fraction here. Now if this is your main axis here, let's say that's the main y-axis, and then this will be your x-axis, then we can kind of guesstimate that this is like, for an x value, that would be like 2/3, and for the y value, that might be like 2/5. So again, we're not sure because we don't have a grid point. Now, if we had a graphing calculator, we could go up along it and then eventually figure out the points. But when you end up with a fraction, something's not on a grid point, graphing is not a good method. It shows what's to be expected. It's going to be some ordered pair where they intersect, and it might be this, but we don't know for sure. That's why we have the other methods. So let's go on. So here they're telling us what we've just said. If they're on the grid lines, you can pick out exact points. If they're not, we'd have to use algebra. And one of the methods, as they're showing us here, is substitution. And that's what I will show you as well. And there are a few different ways to do this, but we'll go along with what I think is a good way in general. Well, first of all, I'm going to identify my equations as equation 1, which will be this, and notice that's in slope-intercept form. We've solved for the letter y. And then we'll label the other equation, equation 2, which happens to be in standard form. Now, we want to solve this. We're going to assume that the y in one case is the same as this y up here, and this value of x is the same. That is, it's going to be some point of intersection where the x and y values are the same for both equations. But notice what we have here. We're saying that y is equal to a negative 2x plus 5. This is what y is. So if I take this value and replace it for the y in the other equation, I'm going to get this. So 3x minus 2. Now our y here is a negative 2x plus 5 equals 4. So what I've done is where there's a y in the other equation, I have replaced that y with this value in terms of x. So now I have an equation with just one letter, x, in it. It doesn't have the two letters. I have substituted for the y in the second equation what I have in the first equation for y. And now I just multiply through. So we'll take this in steps. So I'm going to multiply through now. 3x, a negative 2 times a negative 2 is a positive 4x. A negative 2 times a positive 5, a negative 10. I'm going to collect like terms. I get 7x. I'm going to transpose this to the other side, where a negative 10 on this side becomes a positive 10, and 4 give me, had a little error there. Again, this becomes a positive 10 on this side. So 4 and 10 make 14. Now I'm going to divide both sides by 7. And I get x equals 2. I now have one of my ordered pair members. Now, since I know that x is 2, I can go in this equation here and say y equals a negative 2 times my x value, which is 2, plus 5. So this is going to be a negative 4 plus 5. Y will equal 1. So my ordered pair, if I were to graph these equations, they would intersect at this particular ordered pair point. And if I put this into both equations, it would prove true. And the method I used to solve it was substitution, where I solve for letter y. It was already done. This is my value of y. I put that in the other equation, and I used parentheses because I had to distribute here. I had to be careful of my signs. And I got 7x equals 14, x equals 2. Then I took that 2, put it here in the other equation. I could have put it in either one and solved, and I get y equals 1. And this is what they're doing. They're substituting. And they get 7x equals 14. Notice they're giving you the rationale for doing it. X equals 2. So if x equals 2, we're going to choose that other equation. Again, you can choose either one. You substitute the 2 and do your calculation y equals 1. And that is the solution. And what technique did we use to find it? Substitution. And if you check it, it does check. And caution, this is really important, that sometimes students will find what x is, and then that'll be their answer. No, you have to find the ordered pair. So you have to put that 2 in the other equation and solve for y. Your answer is an ordered pair. Okay, so I've set up the equation 1, equation 2. Now notice in equation 1, we've solved for x. So there's what x has a value of. In our second equation, we're going to take this value of x and substitute it. So instead of an x, I'm going to put this value. And then I distribute. This is 15. This is a negative 5y, I should say, plus 3y equals 5. I'm going to group like terms. 15 minus 2y equals 5. I'm going to take my 15, bring it over to the other side. On this side, it becomes a negative 15, which leaves me then on this side with a negative 10. And I'm going to have a 2y on this side, negative 2y. So now I'm going to divide both sides by a negative 2. Now I usually like to keep my y's positive. That way I don't have to concern myself that I'm dividing by a negative. But remember, if it's a negative 2 here, it must be a negative 2 there. Otherwise, it's not an equation anymore. So these cancel out, and I end up with a y, and this becomes a positive 5. Now I go into this equation up here. I say x equals 3 minus, now our value for y is 5. I put a 5 there. And I get x equals a negative 2. So my ordered pair then is going to be a negative 2 for the x and a positive 5 for the y. And the method I used was substitution. I had what x equaled. I used that in my other equation, putting it in a parenthesis, distributing. I now have an equation with only one letter in it, and I solve for that letter. Then I put it in the other equation once I had that value to get the other letter. Okay, let's check it out. And there's our substitution, our distribution, collecting like terms, solving for y, and we get y is 5. Putting that in the other equation, there's my 5. I get x is a negative 2. And I check it, and it checks out well. And if I were to graph these two equations, this is where they would intersect, right on the grid line. Now, let's take a look at this one, because sometimes you'll have an equation in standard form, and you have to solve for either x or y. Let's take a look. And here's a case where you have x plus y equals 6. This is in standard form. So what do I do here? I have a choice. I can solve for either one. X equals, I'm going to transpose the y, a negative y plus 6. And now I'm going to take this value for x and put it here. So I'm solving for my x. I could have used the y, makes no difference. But there's my value of x in terms of y. I then go and put the value for x where it was, distribute, I get a negative 5y plus 30 plus 2y equals 8. Group my y's together, I get a negative 3y. Transpose this to the other side, I get a negative 30 on this side. Add it to 8, I get a negative 22. And again, I'm ending up with a lot of negatives here, but that's okay, so long as you divide both sides with a negative. This will become a positive 1y, and this becomes a positive 22/3. Now, here's where it gets a little tricky, because now what I have to do is I have x plus, well, let's do it right up here. We want to find out what x is. This is going to be a negative 22/3 because y is a positive, but in this formula we have to make it a negative, and then it's going to be plus. Now I want to make that 6 into a denominator of thirds, so I'm going to multiply it by 1 in the form of 3 over 3, so this gives me 18 over 3, and then we just do our, in the case here it's going to be like a subtraction in a sense, so this is going to be a negative 4/3. So my ordered pair then is a negative 4/3 and a positive 22/3. So here's a case where they wouldn't be on the grid line, and it would probably be very difficult to pick out those fractions from graphing. All right, now let's take a look at it here. And good, they choose the same one we did. We substituted, we got that, we got all that, we got that, and there's our fraction. Now again, for some, getting fractions may make you a little nervous, but you'll just have to handle it as best you can. And then now we put that in the other side, and they did what we did, and they ended up with a negative 4/3. Okay, good. And it does check. And there's a solution. Now, here's a case where we could do it by substitution, but just take a look at what's happening there. Yeah, it's the same slope, but different y-intercepts. So will this have a solution? No, whenever you have the same slopes. Now, another way to solve this, if you have something like that, let me show you another way to do it. And here we can see that y is there. Y equals y. Does that make sense? This y we're saying equals this y. And then we're going to now substitute that this y on this side is 3/4 x plus 2 equals this other y, 3/4 fourths x minus 4. Well, if we subtract both 3/4 x from both sides, we then get the statement 2 equals a negative 4. That is, subtract this, subtract that, they disappear. Now, is this a true statement? And the answer is no. So when you're working through substitution or any method and you get a not true statement like this, there is no solution because the lines are parallel. So that was a shortened version here. Okay? Now how about this one? You recall we did one like this before. If I multiply this one by 2, it becomes the same equation. In fact, that's going to be our next method here, where we use what we call elimination. So let's show you this method. And what we do is we write the first equation. We're going to multiply the second equation by something that will cause one of these terms to cancel out. So if I multiply each term by a negative 2, I'm making an equivalent equation. This becomes a negative 4x. This becomes a negative 8y. And this becomes a negative 16. And if I add these up, I get 0, 0, 0. Now, everything canceled out. Why? Because as we said before, these are the same equations. Now, when we get our final answer, we say 0 equals 0. Is that true? Yes, it's true. So whenever you do, whatever method you're going to use, and you end up with a true statement, 0 equals 0, then the answer will be an infinite number of solutions because they're the same solution. And often we write it in roster notation that looks like this. And they'll usually give you this option as one of your answers. X comma y is such that 4x plus 8y equals 16. You write one of your equations. Could be either one. Okay? All right, let's continue because we have more to do here. And if you use substitution for this, which I wouldn't, it gives you that they're the same equation. Okay, now the elimination method. We gave you a little peek. Here we're going to use the addition principle. The key way of protocol to set it up, the strategy, is to put them in standard form. Well, they're both in standard form. Now, as we look at them, if I draw a line underneath them, I notice what can happen to my y's here. If I add these together, I get 5x. Remember, there's a 1 there. This becomes a 0, and this becomes a 15. Now, I have eliminated one of the letters. That's what this method is called. Set them up in standard form and eliminate through addition, subtraction, one of the letters. And then now we're going to divide both sides by 5. X equals 3. Ooh, that was easy. So now we just put that into one of the equations. It doesn't make any difference. We'll use the first one. 4 times 3, that's our x there, plus 3y equals 8. This is going to be a 12. So this transposes to the other side as a negative 12. A negative 12 leaves this as a negative 4. And 3y equals a negative 4. Going to divide both sides by 3. So I get a fraction, 4/3. So I have my ordered pair as x, and my y is a negative 4/3. Well, let's put a 3 there instead of the x. My x is 3. So once again, I'm substituting back into the one of the equations. I found out that x was 3. So I go 4 times 3 is 12. Transpose that, becomes a negative 12 on the other side. Add it to a positive 8. I end up with a negative 4. Divide both sides by 3. This is my ordered pair. There's our 3. And there's my y. And it does check, as they are showing you here. And the graph, notice 1 is on the 3, but the other part is a fraction. It would have been hard to pick it out, but you can guesstimate. Okay, we're now going to do this one through the process of elimination. We'll do this in pieces 2. So they are in standard form, but the way they are, nothing would cancel out. But if this were a negative 3y, they would. So I'm going to use one of the techniques of multiplying every term in an equation to get an equivalent equation. It's not the same anymore, but it's equivalent. But my middle term will be a negative 3y now. So this becomes a negative 2x, negative 3y, negative 13. So here, when I add them up, I get a 2x. These are just going to cancel out, equals 4. Divide both sides by 2. I get x equals 2. So now that x is 2, I can go into one of the other equations. 4 times 2 plus 3y equals 17. This is going to be an 8 plus 3y equals 17. I'm going to transpose the 8 to this side. It becomes a negative 8. So this will leave me with a 9. Divide both sides by 3. Y equals 3. So my ordered pair is 2, 3. And putting that into MATLAB, you'll see it is correct. And that's what they did. That's what I did. So I got my 2. And then I put that 2 in the other equation, right over there. And there's where I get my 3. So my ordered pair is 2, 3. And it checks. I read this as I read it to myself. Now, as I always say, when we're doing something like this, there is a little bit of artistry in here. Artisan, you're going to use judgment, you're going to use your smarts, you're going to use creativity. You want one of these to eliminate. So as we look at that, and I'll write these again. So as we do this one, I decided I'm going to eliminate the y's because here there's a negative 10, here there's a positive 5. So if I change this equation to an equivalent equation by multiplying each term by 2, this will become a positive 10. And that's what I've done down here. And I'm saying this is equation 1 that I've modified. And this is equation 2 that I didn't modify. But now I get 7x. These cancel out. And here, when I add them up, I get a positive 14. And I get x equals 2. So again, the first member of my ordered pair is 2. Now I can use either equation, and I'll use this first one. You can use the original equation. It's going to be 2 times 2. We just found out that x is 2, plus 5y equals negative 1. So this is going to be a positive 4 plus 5y equals negative 1. Transpose the 4 becomes a negative 4, so I have 5y equals a negative 4 and a negative 1, which is a negative 5. Divide both sides by 5, I get y is a negative 1. So there's my other pair member. And the process I used was elimination. I had to use a little creativity to see what letter I could possibly cancel out. And now let's look at the work. And they're doing what I did by multiplying both sides by 2. And you might say, oh no, I looked at this. No, I didn't. Well, I looked at it, but I didn't remember it. Okay. And there we substitute, and we get that. And there's our ordered pair. Very good. Now, note this. Sometimes both equations must be multiplied to find the least common multiple so that something will cancel out. And we'll see it here. Now, the first thing I would do here, and again, a good protocol to do, is put it in standard form. Because we said the first thing to do in solving these is to put it in standard form. So I just transposed the y's, and I got this. Now what I have to do is, what do I have to multiply this equation by and this equation by so that something will cancel out? Well, since the signs are the same, one's going to have to be a negative. So let's do this one. I think these are the smaller numbers. I'm going to multiply this by a 3 each term and multiply this one by a negative 2. Now in so doing, this will become a negative 6 and this is a positive 6, so these will cancel out. So in multiplying through, I get my 2 new equations. Here now the x's will cancel out. Here I'm left with a y. And here I'm left with a negative 2. So that wasn't too bad. I now have y is a negative 2. So let's do that. You pick any equation. So we have 2x minus 3 times my negative 2 over there equals 2. So this will be 3, what's going on here? I have 3 in my mind for some reason. 2x plus 6 equals 2. 2x transpose the positive 6. On this side it becomes a negative 6, and that will be a negative 4. And we get x then equals a negative 2. So here our ordered pair is a negative 2 and a negative 2. Here you can't go wrong. But always remember, when you put your answer, this is the x term, this is the y term. It's an ordered pair, so order is significant. And I think they'll probably do what we've done, yes. No, I think they solve for y first. Okay, that's okay, doesn't make any difference. Good, I'm glad I did it that way because it's a different way than what was illustrated to show you that you could do one thing or another. It still works. Now, how about something like this? Let's just set this one up. So if I multiply the first equation by a negative 1, this then becomes a negative 2x, a positive y, and a negative 1. Here this cancels out, and I end up with a negative 4. I have 0 equals negative 4. Is that a true statement? No. So there is no solution. These lines are parallel. No solution. And for this one, if I were to multiply this one by a 3, this becomes 9x, 12y, 15. Everything would cancel out if I multiplied by the opposite sign. They're the same equation. So, notice what happens. 0 equals 0. So what's your answer here? Well, it's an infinite number of solutions. Now, for our last example, they're giving us one that's a little bit challenging. What do we need to do first to get rid of fractions? This is from chapter 1. We have to multiply each term by 5, and that's what they're going to do. That is your lowest common denominator, and you get rid of all the fractions, and you now have this. So then, what you're going to do, I would suggest, is you multiply this equation, by, let's say, a negative 2. This is already a negative 2y. By multiplying this by a negative 2 each term, this will become a positive 2y, and they'll cancel out. Again, the tape is getting to be very long, and we could just use that thing here. Or actually just multiply that one. Again, there's different ways to do it. Okay. And it's following the same technique. There's no new skill here. It's just that they had fractions. So here are the methods that we've had in this section. We've had graphing, we've had substitution, we had elimination. Now, when would you use different methods? Well, if they told you to use graphing, then you have to use graphing. But again, if you're not good at graphing, that may not be the best way. Substitution. Suppose you have a letter x equals something, or y equals something all by itself. Then use substitution. Or, again, elimination works in all of them. And remember, there are 3 possible outcomes. Okay, that'll wrap this up.